Welcome back to our investigation of nesting technology and how it can impact your business. In our previous videos, we looked at the shape of the overall nesting problem and began a more in-depth look at how different nesting technologies impact your material efficiency. In this, our third video, we'll complete our discussion on material efficiency and provide those of you shopping for nesting software now or in the future with some tips on how to best construct a benchmark so that it better represents the realities of your manufacturing environment. In most manufacturing environments, a nest with good material efficiency means nothing if it isn't delivered on time. In general, a nesting system must complete a nest in a fraction of the time it takes the machine to run the program, or the machine will sit idle, waiting on the nesting system. There are a number of methods that are used to keep the programming time down to a small portion of the production time. One method is static nesting. Static nests are nests that contain parts that must be produced each time a product is ordered. When the product is ordered, instead of making a new nest, the static nest is run. More time can be spent building a static nest because of its repetitive use. There are 3 cases where static nests are impractical. The first is when the manufacturer does not have repeating orders. The second is when only certain parts in the static nest must be made, such as rework parts. If a static nest is used to reproduce these parts, all of the unneeded parts either become scrap or costly inventory that may never get used. And the third is when the parts in the product do not make an efficient nest. To try to improve the efficiency of a static nest, often custom-sized raw materials are used. There are 2 drawbacks to using custom raw material sizes. The first is that it can lead to excessive raw material inventory. The second is that custom-sized raw material usually incurs a penalty of several percentage points in increased cost per pound. Because of these limitations, many manufacturers turn to dynamic nesting. But while these systems are more flexible than static nests, some dynamic systems can produce slow and unpredictable results. As discussed in the first video, list-driven systems can be fast enough, but if the efficiency results are not adequate, then more variations of the list must be run. While this may produce better results, the increase in permutations can quickly increase the time needed by the nesting system to unworkable levels. Another area that can consume production time in dynamic nesting systems is manual interaction. If the nesting system requires human input to run, then not only is more time required, but the end result is no longer predictable. Fully automatic systems take the least amount of time and produce repeatable results. These systems require a higher level of integration with CAD and ordering systems, so the initial investment of time is higher. If you don't have the systems necessary, some amount of manual ordering or part entry may be required. But if you do have a CAD system and a system to manage your order flow, then full automation will produce nests faster than any manual or partially manual system. When considering a nesting system, you should take time to understand the impacts of programming time on your operation. Is your current time between machine cycles measured in days or minutes? If you don't run your machines very often, then a slower system may be acceptable. Even more importantly, you should ask yourself what benefits could be gained by increasing the throughput on your machine by providing it with nests more often. Benefits range from better support of downstream demands all the way up to avoiding new machine purchases. Current nesting systems vary from fully manual to rapid just-in-time programming. With knowledge of how time impacts you, you can better judge which system is best for your needs. Now that you know what you need to know about material efficiency, it's time to consider how to judge between the different vendors you may be considering. It's time to discuss the benchmark. Benchmarks, if done correctly, can measure many different qualities of a nesting system and provide accurate estimates of the cost savings you can expect. Before we get into the specific things to look for around material efficiency, there are a few general rules about benchmarks you should consider. First, benchmarks must represent reality. It does no good to present a special case set of parts or unrealistic quantities to a benchmark. The results of the benchmark, when compared to your current performance, would be meaningless. Related to this is our second point. One of the competitors in the benchmark must be your current system. This is the best place to look for an accurate set of data. Pull the parts and quantities you ran for a period of time, along with how well your current environment performed. This will give you and the vendor a baseline from which they can calculate an estimated return on investment. The third thing to look for is a large quantity of scheduled orders. Not only do you want to use real orders and schedules, you should use a lot of them. A common mistake is to limit a benchmark to just a few orders with little or no definition of schedule. These benchmarks risk missing important segments of your production needs and don't accurately represent your mix of parts or true scheduling demands. You don't want to purchase a system only to have it fail under real-world conditions. Another good tip is to include changes in your benchmark. If you run into hot parts or reworks or any other change in your schedule on a frequent basis, include this in your benchmark. Make sure this part of the benchmark is run live, with the changes being dictated at the time of demo, so you can judge the speed of the system and its ability to adapt. Since benchmarks can take several days to complete due to part programming and technical exchange, it's important to see the nests run live both before and after a change in order quantity and schedule. This will reassure you that the results represented were not manipulated outside of the software's normal operation. It'll also give you an opportunity to see how changes are made and nests created, so you can understand the level of manual interaction required by the software. If there is a significant difference in performance after the changes were made, be sure to discuss this difference with your vendor. Finally, to get the best measurement possible for material efficiency, allow the orders provided for the benchmark to be circular. What this means is that the end of the order schedule is followed immediately by a repeat of the beginning. The benchmark would end once all of the original parts were placed on a completed nest. Without this, every system you test will experience tail-off as the orders run out. With this small change, good systems will have the parts they need to succeed, and only systems that cause their own tail-off due to poor part management will experience the problem. The only time a benchmark nest should run out of parts on an order is when your actual production environment would also have run out of orders. This is a rare case. Benchmarks are great tools, but they're not enough. Visit or talk to other companies that are similar to you. Support and upgrades are very important. Find out about the support system that high-speed dynamic manufacturing requires, and make sure you have a nesting vendor that will be a long-term partner. All of these investigations should be part of your full evaluation of a nesting system. There are many pitfalls in designing a benchmark. We'll be happy to assist in designing a benchmark that will reveal the true economic benefits for your specific circumstances. This concludes our series on material efficiency. We hope that the information provided here has helped you in your understanding of nesting systems and how they achieve material efficiency. Please continue to watch our series on how to evaluate nesting systems as we move on to discuss throughput and meeting your production schedule. Thanks again for your time. If you'd like more information about Optimation or any of its products, or if you just have questions about the material presented, feel free to contact us by either phone or email. Optimation provides professional products with full professional-grade service. Our technologies are found nowhere else. Whether you have just one machine or many, this technology will deliver world-class economic performance.